anybody super anxious. The only reason I'm doing that is so I can put it up on the internet, so if you miss a day, I'll be teaching this class in the morning and afternoon, so if you miss a morning class, you're always welcome to come to the afternoon class. It's immediately after this, in this exact room. There's literally a 10-minute break. I say, get out, and I eat lunch, and then start again. This class is Math 261. It's beginning algebra, so it takes you through, from order of operations through polynomials and quadratics. Some of you might have taken this before. I might be repeating. Some of you, it might have been 10 plus years since you've taken a math class. That's totally okay. I'll tell you a little bit about myself, and then a little bit more about the course, and then we'll just get started today. Okay, my name is Brendan.dilloughery. I like the Spanish way of spelling my name. My last name is just 3 syllables. They're really easy. You can't go wrong as long as the emphasis is in the middle, so it's dilloughery. I've been teaching for about 7 or 8 years now. I teach middle school and high school mostly, a lot of math, a little bit of science. I taught for 3 years in Scotts Valley at the middle school, a lot of algebra, geometry, things like that. I went to Ecuador for 2 years and taught science in Ecuador for 2 years. That was fun. I built international school for rich Ecuadorians. Then I went to Switzerland for a year and taught high school math in Switzerland for a year. Came back, and I've been teaching at a little private school in Watsonville for a year and teaching at Cabrillo for the year. And yeah, now I'm teaching here for the summer. This is like my 3rd time ever on MPC campus, and then I'll teach over in Los Gatos, Mountain View area next year. So I like moving around, I like change. But I've been teaching math for about 7 years. I'm very good at math. I went to school at UCSC, got my bachelor's in math, got my master's in math, got my master's in education. For all you guys, wherever you are in college, I'd say stay in college for like 10 years. It's really expensive, but it's really fun. And then when you come out, you have all these degrees, and it's easier to get a job, so it's nice. So, as I said, this class starts from basic algebra. I mean, the first couple sections we're doing is adding, subtracting negative numbers, order of operations, things like that. Quickly we go to chapter 2, solving equations, just 1-step equations, 2-step equations, and it builds up quickly. All the important stuff happens at the beginning. And you might think otherwise, you might think, man, it gets so much harder at the end. But everything important happens in the first few days, if not the first week or 2 weeks. The reason being is we reuse that stuff over and over and over. So if there's any time you're going to put in hours of extra work, make it today and tomorrow and the next day, because this stuff is the stuff that will literally be used on every assignment, in every section, in every chapter for the entire 7 weeks. So I got something in my throat today. I want to say that. I really want to say something that's affected me a lot in my teaching in these last couple of years, which I really made a point to emphasize in my Cabrillo classes this last year, and I've had a lot of success. And that is, regardless of whether you consider yourself smart or otherwise when it comes to math, or I'm a math person or I'm not, studies across the board for decades and decades have shown that success in math is really just hard work, not innate ability. And people who believe it's innate ability actually shoot themselves in the foot and do worse than people who believe it's effort. And I'll mention just a couple studies. There's a really famous study from the 80s done by this, I believe, psychologist named Dweck. And what she did is she took a bunch of her students, right, that, actual professor doesn't actually do any of the labor, she just sends off students to do the work. But sent kids in New York to some 5th grade classrooms. This is across hundreds of kids in multiple different classrooms. What they did is really simple. They gave the kids a puzzle that was too hard, and at the end, they said 1 or 2 comments, or a control group said nothing, right? 1 sentence of praise, randomly drawn from hat. And so what they did is they told these kids, after doing this really hard puzzle, little 5th grade, sweet, adorable little kids, They said either, wow, you're really smart. Wow, you really worked hard. Or they said no. Okay? And then they followed these kids as they did more tests and more tests. And what they found is the kids they said, wow, you're really smart, when given the option to, do you want to do a harder test or do you want to stick with the same one? All the kids who were told, wow, you're smart, chose to do the easier test because their reward, their satisfaction was, hey, I did it. I don't want to challenge myself with something new. I don't want to possibly do something that I can't handle. I'm going to choose the easy test over and over, okay? The people who were told, wow, you really worked hard, chose to go on to a new test. And then when they did that next test, the kids who were told, wow, you're smart, were stressed, anxious, worried, unhappy, did not enjoy the test, did not enjoy the struggle. The kids that were told, wow, you really worked hard, had smiles on their face and were saying, man, this is my favorite puzzle, this is so hard, this is fun, I'm really trying. They purposely gave the people, all the kids, regardless of what decision they made, a really hard test that not a single person could pass. And then the very next round, they gave them an easy test, just like their first one. And what they found is, the kids that they said, wow, you're really smart, given the exact same test after experiencing a challenge, did about 25 to 30% worse than they did on the first test. Because they thought, either I'm smart or I'm not, either I get it or I don't, I was born that way, and there's no need to put forth an effort, and they did worse on the exact same test a few weeks later. Whereas those people who were told, wow, you really worked hard and were rewarded for that, given a challenge, and then given the exact same test, actually improved upon their scores and did about 20, 30% better. And this sort of stuff has been shown across the board. Another example was I was reading Malcolm Gladwell's Outliers, Story of Success. Great book, interesting, funny. And it was about the international math competition that the US sucks at. Other countries, get top, Scandinavian countries, Asian countries usually do the best. And what they found was this really interesting correlation. And it was, they give this grueling questionnaire right after they do this big math contest, so you just, worked your mind as hard as you could, and at the end, they give you this really long questionnaire, like hundreds of questions. And so it's just, okay, go as long as you can. And inevitably, people would not answer every single question, this like 100+ question questionnaire. And what they found is, the number of questions completed out of 120 questions or whatever it was, correlated to where that country scored in the Olympics, really accurately. So, on this test, the top country pretty much answered every single question. And the lower countries gave up on that rigorous, tedious, oh my God, hundreds of questions, I quit. And so again, that hard work showed that the harder you work at some grueling, tedious task over and over and over practicing it, the better you do on this competition. Okay, one last one. This was actually Dweck again. So she did that first one in the 80s, and it got tons of fame and everything, but she's still alive, she's still working. So what she did is just about 5 years ago, went to New York again, this time in high school, and took a bunch of kids in a failing high school where more of their kids drop out than graduate. And they went in and they took all these kids and they split them in two, because you always got to have the control and then you experiment on the others. And what they did is they gave them a study skills class to just practice math, learn study skills, right? And over the course of one semester, the only difference between the two groups is one group got 50 minutes of specialized instruction, so 2 25-minute periods, that's it. So this wasn't like an ongoing, we're working with you every day for a semester. It was literally 2 class periods. And all they did was tell the kids about how every time you challenge yourself, every time you work through adversity, a difficult situation, your brain actually makes new connections, grows new neurons, so that it's stronger, just like a muscle. When you go to the gym and you work out, as long as you get a healthy workout and you rest after, you're eating, whatever, okay? But when you challenge yourself, you actually grow new neurons and you do get smarter. And so whether you're smart or not is not something you're born with. It absolutely comes from hard work. And the more you work hard, the more intelligent you can get. And what they found was that they completely, so over half the kids dropped out in that school. And of that cohort where they did that, they completely reversed that trend and it went from over half dropping out to over half succeeding, and it went to an uprise in that class's grades, which I just thought was amazing. I mean, 2 25-minute periods, just saying, if you work hard, you can grow smarter. I mean, anecdotally, they wrote in there that some of the kids were in tears over this and things like that, but that's not scientific. But actually, went from more kids dropping out to more kids staying in school, and an overall rise in the grade. So I want to mention things like that, and just really encourage you that if you're going to put in a lot of hard work, which this class takes, do it these first days, do it on order of operations and solving equations, because that is the most important thing in this class. And I'll say the most important thing in the class is section 1.1 and 1.2 and 1.3, and then chapter 2, because chapter 1 and 2, which we go through so quickly, sadly, you're literally going to use on every section and every chapter for the rest of the class. Okay? Do you guys have any questions for me? No? Okay. You guys are a silent bunch. I know it's 8 a.m., so people are still tired, people are still waking up. I had the joy of waking up like 2-3 hours ago. I live in Aptos, and I like eating a nice breakfast, driving out here, and reading an audiobook, and then I got here way too early just for fun, so woke up a long time ago. Just make sure I did everything. Oh yeah, so one more thing. So I don't have office hours here, sadly, which is a weird like summer school kind of thing. So right after this class, there's a 10-minute break, and then I teach the same class again. So again, if you're ever confused about the day, just I want to see this again, absolutely just stay for the 11 to 2 o'clock class, or go have lunch, come back in the middle of the class because it was the second half of class I didn't get, go for a walk, come back, but you're absolutely welcome to come to either or both. As I said, I'm videotaping the class that I'm just going to put up on the internet, so if you miss a class period, I mean, I will hopefully go home, put it on the computer, and put it on the internet that day, although I have a 2-year-old, a 1-year-old, and a newborn at home, so I don't know if that's realistically going to happen within hours of class every day. But that's my goal. At least by the end of the week it'll be up. Okay? And yeah, I put up my lecture notes, so I write out notes like this for myself, like what I'll talk about, what I'll write on the board. I mean, I'm open to flexibility for sure. But I write these up, and I scan them, and I put them up on the website. They're all already up there. The beginning ones are okay, because originally I was just doing it for myself, and then students really wanted it, so the latter half of the semester are much better, so I'm redoing them as we go. But it's all up there on the class website right now, so there's lots of resources. So really what I'm trying to say is it's all on you guys. And I know, maybe we should start just book math right away, but I want to emphasize for as much time as I can, it's on you to do the hard work, to learn from your mistakes. If you don't get it, don't give up. Try again, work hard, don't stop, especially at the beginning. And I will put videos online, I put my notes online, I have a website with practice exams going back for years of this same class. The tests are going to be remarkably similar, different numbers, different words, but the same exact type of question. Everything's out there. You could not come to class once and you could watch the videos, do the homework, check the notes, but I mean, I strongly encourage you to come to class every day. There will be homework every night. Now, I'm only going to collect it on Wednesdays and on Mondays, which is essentially every 2 days. So Monday and Tuesday's homework, I'll collect on Wednesday. Wednesday and Thursday's homework, I'll collect on Monday. I would strongly encourage you to each day do all of the homework, come in the next day with questions, saying, hey, I didn't understand number 2, I didn't understand number 7, I didn't understand whatever. And we can start for the first half hour, 45 minutes of class, going over questions. I love that. Because you don't learn just sitting there being like, oh yeah, he's doing it, I see it, that's cool. I could imitate that, I could do that when I get home, and then hours later, you've had lunch, you've texted 100 people, you've done whatever, and then you sit down and you're like, wait a second, I don't remember every little trick for 3 sections that we went over in a 3-hour period. So I would strongly recommend doing the homework every day, coming in with good questions. So as I said, I don't have office hours, but the MLC is right next to us. If you just walk out this door and go in the building, that's the MLC right there. It's open 10 to 2 every day. So immediately when class ends at 10:50, you could, get some lunch, walk around in the sun, then go over there and do your homework for an hour, 2 hours with free tutors there, and just say, hey, I don't know how it works here. This is like my 3rd time on campus, but it's a math learning center. You just say, hey, come over, please help me. I've got a question. I don't know if there's a sign-up sheet. We're actually going to walk over there towards the end of class and physically walk into the room and ask them how the room works. But that's a resource, free tutoring. Okay? The entire class could show up for one person. Doesn't matter, they're there, they're open, it's free, Monday, Tuesday, Wednesday, Thursday, and I believe Fridays too. So even if you want to spend your Friday, but you don't have class, come in and get help instead. So still no questions for me? Yeah?
You said for the tutoring it's 10 to 2?
Yeah, 10 to 2, 10 to 2. This is the class website. There's no www, and it's popular without an A. This is some free website that I got shown. I was trying to bring it up on the projector, but it's all locked up. Oh, hey, it finally turned on. I can show you it on the projector. There's a remote to turn on the projector. We'll get there. This one on, power, projector 1, projector 2, we're turning everything on. It's probably going to show up in multiple places. It's good. Okay? So I'll show you the website really quick. It's got everything I can possibly think of that you may need. I really want to make it as accessible for you guys as possible, so anybody who wants to work hard absolutely can succeed. I had a student, I just taught this class at Cabrillo, same course, same book, same homework, same test, and I had a student say, like, hey, do you think, I could pass the next course there? It was 154 and then 152, the numbering systems are crazy. But could I pass the next course in summer? And I was like, man, that's a question you gotta ask yourself, because I think anybody could pass it. But it's just, are you willing to spend hours in the middle of summer, when it's hot, and your friends are at the beach, are you gonna say, I'm gonna stay here and do 2 hours of math homework, and take it really seriously to the point of, I checked my answer and it's wrong, I'm gonna look back and figure out why and rewrite it showing my work, or are you just gonna scratch some stuff down on paper because I want some points for the homework, and I don't really care if I'm gonna do it, I'm gonna spend half hour, then yeah, I don't know if you'll pass. Okay, if it's 100% up to you, everybody here can pass. And I think in my last class, I think the average was like 25% pass rate for the school. I think in my last class I had, you start with 40 or something, and at the end of the class, I think I ended up having over 20 pass. I mean, it was a very high pass rate. I really encourage people to work hard, and I will help you in every possible way imaginable. Okay. Should pick it up. It says no signal. Let's see. Come on, computer one. Look at that. No. It's still cycling through. Let's see if it works. Nothing. It didn't pick up. Let's try one more time. So guess, extend. No, it doesn't say guess computer. Let's try this. There we go. Above. One more try. If it doesn't work, that's okay. Got it. Try it. Okay. Let's try that. There's lots of inputs here. Buttons on this. I'm used to Cabrillo. There's just a wire sticking out that I can plug into my computer, and I'm pretty savvy. But this is old technology. It's VGA cable, and my laptop only has HDMI, so it can't connect to my computer. Oh well, it was a good attempt. We tried. But the website's there. Okay. One last thing I'll tell you about the class is just how the grading works. So the grading is mostly tests. I wish it was a little more based on homework and effort rather than just tests, but in reality it's a college class. The question is at the end, can you do the math? So there's 4 tests and a final. The 4 tests are each 100 points exactly. The final's 200 points. So total, that's 600 points. And then homework is 1 point per section. Seems like a very small amount at first. So we'll do 3 sections today. So that'll be 3 points worth of homework due tomorrow. On any given day, we'll do about 2 to 3 sections usually. So every day we'll have about 2 to 3 homework points possible. At the end, that'll total, I think it's like 43 or 45 points. So it'll be about 600 test points, about 43, 45 homework points. What that means is, if you choose not to do any homework at all, whatever grade you got on the test, subtract 7 or 8% from that, and that will be your class grade, because you would have a 0 for that 7 or 8% of your class grade that is homework. So I would strongly encourage you to just take advantage of that homework margin there that bumps up your grade. And then the one other kind of wild card that's different for me, or different in my class than for other classes, is I strongly, strongly encourage you to learn from your mistakes in life and in math class. I think that's, you know, the mark of just a quality person, somebody who works hard and learns from their mistakes and just grows in every way as they go through life, rather than just a downhill slide at whatever high point in your life. And so I encourage you, with grade points, to revise your tests. And what that means is, whatever test score you get, even if you get a 98 or a 99, go back and correct your test. I have instructions for test corrections on the class website. After the first test, I'll go over those in more detail with you. But basically, you go through every single problem where you got even a single half fraction of a point taken off. You redo the entire problem, and then you write a sentence about what you know now, so that I know, in your own words, you can do the problem correctly. And what that gives you is up to 10 points back on your test. Now, if you scored above an 80, I only give you half of the points back that you missed. So if you got a 98, you only got 1 or 2 problems to correct, but you could get 1 point back and get 99. If you got a 64, you can get the full 10 points back and get a 74. Okay, so it bumps up an entire grade every single test other than the final. Okay? Strongly, strongly, strongly encourage every single person here, whether you're serious about, you know, the class or not, to do that. Because especially at the beginning, when you are literally going to reuse every single thing you learn in chapter 1 and chapter 2 over and over and over and over and over in every math class you ever take. Correct that test. Really try and learn from your mistakes. And the sentence is, I don't want to see things like, I wrote 4, I should have written 6, I don't care. Or you're like, oh, my mistake was, I don't really care what your mistake was, right? That's in the past, you made that mistake. Now learn from it. Write a sentence like, now I know that when there's parentheses, you have to distribute in the negative. Or now I know you can't cancel one thing on the bottom with one of the things on top, because this bar right here implies this is in a group. So a sentence they're saying, oh, I can't cancel that 3 with that 3 because that top 3 is part of a group. That's a huge idea, right? And just saying that sentence, I'm like, oh, they get it now, right? They get it. They'll do okay in the next one. Okay. So, enough about that. Are you guys ready to start with some math? Right? Nice 8:25, wake up in the morning. Okay. Go. See how these pens work. All right. So the first thing we start with is probably the single most important thing in algebra, which is order of operations, right? First thing you need to be able to do in algebra is, if I give you a pile of numbers, which is how every problem in this class will end, right? Can you give me the right number, right? I'm like 2 times this, plus that, minus that, divided by this, right? You have to be able to tick that final step and get me the right number. So we're going to talk about that. Please excuse my dear Aunt Sally, except I write it a little differently and have a few hints that have helped me over the years. Alright, so again, single most important thing in this class, this is section 1.1, introduction to algebra. And again, the notes for all these will be online. They're already online, although my last semester's first few ones are a little scant. That's why I made new ones, and I'll scan them and put them up on the website. But again, when I get home, it's 2-year-old and 1-year-old climbing on me and holding a newborn. It's a little crazy. All right, so first one. Looks like this, right? A little different than you may have seen it. Rather than please excuse my dear Aunt Sally all on the same level, as if multiplication came before division and addition came before subtraction, that's not true. Okay, multiplication and division are actually the same operation, and addition and subtraction are actually the same operation. So that's the first thing. Okay, the second one is I've got a couple of hints. So for parentheses, I got 2 hints. And the first one is one of the most important because it's one of the most common mistakes I see in this class by far, and we'll talk about it over and over in a couple different ways. But the first one is there are implied parentheses. And these are missed often. I just actually gave you an example, and I'll give that same example in just a second. But what I mean by that are horizontal lines imply there are parentheses. Okay, I'll give you a couple examples of this just off to the side. So here's an example. Square root of 4 plus 9. Okay, this horizontal line right here, going from here across multiple things and stopping here, that implies that there's a parenthesis. So before you start anything else, you have to do 4 plus 9. So this is equal to square root of parentheses 4 plus 9, or square root of 13. Okay? Not square root of 4 plus square root of 9, which would be 2 plus 3 is 5. Right? So first, before you do anything else, come parentheses, and this is a huge mistake people make, is not understanding that horizontal lines mean there are parentheses there. Another example, this one is the most common mistake I probably see, or at least one of the 2 or 3 most common mistakes, and that's when you see something like x plus 3 over 30. Okay, I gave that example just a second ago. Super common mistake. When there's a horizontal line like this, it implies that everything above and everything below are a group. Absolutely, you can never, in the entire time we're in this class, cancel something on the bottom with one part of this group. There are parentheses here. This entire group is an inseparable chunk, an inseparable block, and so you absolutely cannot cancel this x plus 3 over 3 and get something like x plus 1. So not, definitely, in no way is that ever possible this entire class. And that's going to be a really common mistake. Okay? So that was the biggest one. The other one, small little hint. Okay? If you have nested parentheses, okay, start from the inside. And work outwards. Okay, you can't really start with the outside and work inwards anyways, but just want to specifically bring that up. Okay, so an example of this is something like 5 times 2 minus, in parentheses, 3 plus 2. Okay, so now I've got parentheses inside parentheses. These square brackets you're going to see pretty often in this class. They're exactly parentheses, 100% exactly. There's zero difference. Okay, the only reason we use it is because if you have something like this, round parentheses, round parentheses, round parentheses, and then you've got like minus 2 round parentheses, and like 3 plus, and you've got round parentheses, it's like, okay, well, which round goes to which round, and it starts to get confusing. And so that's why we alternate. We go round parentheses, like 2 minus 3 plus 5, square parentheses times 2, and then plus 1, and then the next one would be round parentheses. And continually I make them larger and larger, but we alternate round, rectangular, round. But otherwise, absolutely no difference. Exactly normal parentheses. Okay? But we'd start from the inside out. So on this one, we would do this parentheses, but inside of there, there's another parentheses, so we would do that first. So this would be 2 minus 3 plus 2 is 5. And I rewrite the entire expression. Okay? Then I do this parentheses, 2 minus 3 is negative 3, with the 5, and then multiply, and I get negative 15. Okay? Just 2 little hints there with parentheses. Okay? Now with exponents, okay, right below that, this is step 2 in order of operation. There's really one hint, but this is, again, one of the most common mistakes you see in algebra. Okay? We really hit 2 of the most common 3 or 4 mistakes right here, just the order of operation. Okay? The big hint is only apply to the first thing immediately on their left. Okay. More specifically, does not include the negative. Negative sign, unless there is a parentheses. Okay. So, I'll just give you an example or two of that. Okay, so here's an example where we've got negative 2 squared. So if I look at this square and I say, okay, what does this squared hit first? If I take a line and draw towards the left, it hits the parentheses. So I know it's the parentheses that are being squared. So this is parentheses times itself. Okay, I don't care what's in the parentheses, I know that exponent is only affecting, it's only squaring the parentheses. So this is negative 2 times negative 2, which is positive 4. Okay? The one that everybody gets wrong is negative 2 squared. This 2 is now only affecting the 2. And I specifically said here, it does not include the negative unless there's parentheses. So this is negative 2 times 2, or negative 4. And this is a big one. The people, I want you guys to ask questions. If you're confused, I had somebody ask a question, and we went over this, and continually this came up on tests, and people stumbled. Okay? I'll tell you a couple reasons why this is, okay? One way to think about this is negative 2 squared is kind of like negative 1 times 2 squared. Now that's going to confuse you and say there's no negative 1, there's no multiplication, that's ridiculous. Okay, another way to see this is, let's think of an example. Okay, let's look at an example like, what if we have 5 minus 2 squared? Okay, that's still minus 2 squared, right? That negative sign does not get sucked into the 2 squared. Order of operation says the very second thing after parentheses that happens is exponents. Exponents happen next. So the next step in this should be 5 minus, and 2 squared is 4. Now a lot of people would get that right. However, on the very next problem, if I just said what's minus 2 squared, which you can think of as 0 minus 2 squared, right? A lot of people would say that's positive. So in this case, they'd say it's negative 4. And in this case, they'd say it's positive, right? So that's another way to think about it, okay? One more similar way to think about it is, okay, what if I have 3x squared? Okay, what's being squared? Just the x, right? Some people mistakenly say, right, this should be just 3 times and then x times x, because just x is being squared. Some people mistakenly say, oh, this is 3x times 3x, right? But that exponent only affects the first thing. So regardless of whether this is a number like 3, or if it's a number like -1 x squared, right? That number does not get sucked into the square, okay? So just a couple different ways to think about it. But that's the common mistake I see with exponents. Otherwise, it's just arithmetic, you know, so people are like, oh, 3 squared, and they accidentally write 6. And that's just, slow down, be careful, right? That's not as big of a mistake because people don't usually think that when they're calm and clear-headed, they just get a little anxious during the test, okay? But that one is a conceptual problem that people do have, all right? Questions here? I know it's early in the morning, I like that I heard my first voice, this is good. Questions? Oh, all right. We'll get up in a little bit, we'll take a break, you can do some push-ups, get some blood flowing. All right, so next, multiplication and division. I write these together because these are actually the same operation. Okay, my math teacher in high school, who I loved, is a great math teacher, always would say there's no such thing as division, there's no such thing as subtraction. All division is multiplying by the inverse. All subtraction is adding the opposite, right? And that's, I mean, what's the first thing you do? Just, this doesn't need to be part of your notes, but if I have, 5 divided by 1/2, I mean, how do you do divided by 1/2? And we'll talk about this in a minute. If you don't remember, if it's been years since math, that's okay. But does anybody remember? Yeah, multiplied by the reciprocal. So immediately, you don't even do division. There is no division. You switch it to, oh, that's actually times 2/1. Because really, division is multiplication. It's just multiplication of the inverse or of the reciprocal. Okay? So that's why these actually happen at the same time. And we'll talk about this more and more as we go forward, and hopefully this will be more clear. Okay? But the big thing here is in order from left to right. That's it. You go in order from left to right. Multiplication does not come before division. You just go from left to right. Okay? This doesn't actually cause that many problems usually, because we don't usually write divided by like this. Usually we write divided by as a division bar. So the whole order of which comes first doesn't matter as much. You can just do this chunk divided by that. So this actually doesn't cause that many problems because we use a division bar instead of this little division sign. Okay, but the next one causes all sorts of problems. Okay, I'll give you one example of this. Okay, 4 divided by 2 times 2. And I'm specifically giving you this example because this is an example where I just come out of school, just got my master's in mathematics, right? Do crazy stuff where once you go through a certain level of college mathematics, you stop using numbers, right? That's weird. And you go back and you do algebra, and you do calculus, and you do all these classes, geometry, except you forget the whole number system, and you just use x sub 1, x sub 2, and you use what if we were in a 17-dimensional space, and what if we were in a universe that can't exist, but does exist all around us, right? So going through that, I come back and I start teaching a 6th grade math class, my first class I ever taught, and this problem comes up, and I get it wrong. Totally, because I'm thinking in my head, please excuse my dear answer, multiplication comes first. It doesn't come first, right? You're supposed to go from left to right, and I got this wrong teaching a 6th grade class and had to go back and relearn some stuff. So that's one of those lessons that can definitely mess you up. So from left to right, this should be the division first, not multiplication. So this is 4 divided by 2, and then times 2, which is 4. A lot of people, right? A lot of people would say multiplication first, this is 4 divided by 4, or 1. Right? And that's the problem that I got wrong, so don't feel bad if that's, the way you learned it. Okay. All right, and finally, this one is the other most important, because this one causes so many problems. Okay, so addition and subtraction. Again, my math teacher used to say, there's no such thing as subtraction, there's no such thing as subtraction. And I'll go over a way that I learned to deal with this, but one way to do it is in order from left to right. Okay. Right away, saves you from those mistakes. However, if there's 10 things in a row, doing, the first 2, rewriting the whole thing, the first 2, rewriting the whole thing, the first 2, rewriting the whole thing, I mean, that can be really tedious and recursive. But I'll show you the way that I actually do it. And I'm not joking. I mean, when I make the keys for your test, I show every step, because it would be really embarrassing as a teacher to score like an 85% on the math test that I created for you guys to take, right? So I'm very careful. I don't like making mistakes. I'll always choose the safest route. So I show all my work, and you can watch. This is how I actually solve these problems. Okay? So the second way I do it, this is the second hint for this, is smarter. You'll hear me use this word. I make up some weird phrases. I don't make these up, actually. A lot of them come from past teachers that I've worked with or that taught me. But smarter. What this means is subtraction means adding the opposite. So 2 quick examples of that are, what if I have 5, let's even say -5 minus 2, because negative signs just mess people up. So many problems are just negative signs in math. And the other one would be, okay, what if I have 1 minus -7? Okay, so subtraction means adding the opposite. So -5 minus 2 is the same thing as, -5 doesn't change, right? So the first one doesn't change, that's like the rock. And then what do we do into it?
Yeah.
Adding what? So adding -2. So one way to think about it is you can make 2 pen strokes to change it. So for smaller, you'd say, okay, instead of subtracting 2, we're adding -2, okay? And you say, okay, that doesn't look a whole lot different. I'll show you why. Right here, -5 minus 2, so many people say, 5 minus 2 is 3, and they say it's -3. Right, that's not the case. Here, when you've got -5 plus -2, that's really easy. I've got 5 negatives and 2 negatives. Obviously, when they go together, I've got 7 negatives. Okay, same thing here. Okay, 1 minus -7, what does that become?
1 plus 7.
Yeah, exactly. 1 plus +7. And so again, 2 strokes, change this sign, change this sign, then all of a sudden 1 plus 7 is a super easy problem, right? That's 8. Now the way I do my problems, which for sure, the first test, one of your first problems is going to look like this. Okay, it's just going to be a big line of addition and subtraction. It's going to say -2 plus 11 minus -3 minus 4 plus -1 plus -6 plus 2. All right, one of your very first problems on the first test is going to look just like that. I'm just going to make up some numbers, plus, minus, positive, negative. Okay. So the first thing I do is I smile. Okay, I go through and, okay, it's plus, I don't care. This one I'll smotto. Okay, this one I'll smotto. Okay, this one's a plus, I don't care. This one's a plus, I don't care. This one's a plus, I don't care. Then what I do after I smotto is I collect up, and I'll write this down. collect all my positives together, right? So every positive just collects together. So I say, okay, I've got, and when I circle this, I circle the plus sign, because that sign tells me whether it's positive or negative. I say, okay, I'm gonna take all my positive numbers. How many positives do I have? I have 11 and 3 is 14, plus 2 more is 16. So I have 16 positives, plus, and then I collect all my negatives together. So I'm only doing addition, right? So all my negatives, -2, -4, that's -6, -7, plus 6 more, -13. And then only one time at the end do I actually do subtraction. So at the end I say, okay, 16 plus -13, that's 16 minus 13, that's 3. Okay. So I'll write that out right now, but that's the way that I actually solve these problems. Okay. So first motto, first I change all these subtractions to adding the opposite. Collect all positives, collect all negatives, add the positives and negatives together. Okay. So for me, that's always worked, from whenever I learned it until now, and I still do it. Okay, and you'll see as we get order of operations coming up more and more, I'm not gonna go more into it now, because really it'll come up towards the end of chapter 1, where you're really challenged. At the beginning here, it's just gonna kind of be adding two numbers, multiply first and adding. But the way I see it, now let's come to it later. Okay, so that's it. Are there questions about order of operations so far? So I gave you a couple hints for each one, but really, big overarching steps is get rid of all the parentheses first. There should be no parentheses left, and that's regardless of whether you're solving an equation or whatever you're doing. First step, get rid of all those parentheses. Next step, are there any exponents? Okay, let's get rid of those. And then multiply together all the terms. And finally, the last step of every problem is going to look like this, just a bunch of addition, a bunch of subtraction. Okay? All right, that's good. Questions on that? Okay? No? All right, so there's two other things I want to talk about from 1.1, two kind of basic ideas. The next one being, what's an expression and what's an equation? And I can't emphasize enough how much each of these ideas comes up over and over and over and over and over again in the future. Okay, and after I give you these two vocabulary words, we'll take a break. Alright, so some quick vocabulary, which is expression. Versus equation. Right? Can anybody tell me the difference really quick?
Equation is all an equal sign.
That's it. That's really it. Okay? These have an equal sign. And set two expressions equal to each other. Okay? An expression is a little harder to define, but does not have an equal sign. single number or a combination of numbers, variables, and math operations. Okay, so some examples here. Here are expressions. And here are equations. The reason I'm telling you this is because this will come up off and on, never in like the define what an equation is on a test. I mean, I would never ask you something as arbitrary as that based on memorization. But it will come up in, evaluate the expression, simplify the expression, solve the equation. So you need to be at least comfortable with the vocabulary, even if you couldn't give a rigorous definition. Okay, so the expression might be something like 5. That's an expression. A really common one, x plus 2. Okay, it might be something that looks a little scarier, like x squared minus 2x plus 7. Okay. Equations could be as simple as x equals 1. It could be a little more complex, like 2x minus 3 equals 8. Okay. Or again, it could be something like a quadratic, like 2x squared minus 3 parentheses x plus 1 equals 5 minus x. Okay. The big idea is an expression is not something you ever solve. All you're going to be doing is simplifying it, trying to write it as simply as possible, or evaluating it. Like maybe I'd say, hey, x is equal to 7. Evaluate this. So you'd say, okay, 7 plus 2, this is equal to 9, if x is 7. Okay, this one I could say x is equal to 1. Evaluate this for x is equal to 1. You plug in 1 and you say, okay, 1 squared minus 2 times 1 plus 7. And you see what it's equal to. Okay, but you're really just simplifying. Over here, when you have two things equal to each other, you have this balanced scale, that's when you're actually told to solve. Figure out what x has to be for this to be true, for this to be equal to this, figure out what x has to be. So the whole idea of evaluate or simplify versus solve, okay, and that's what we're going to talk about next. But let's take a little 5-10 break, go outside, get some fresh air, stand up, move around. It's early. If you have any questions, come up, ask. Please do stand up. Don't just stay in your seats. At least just walk. Oh yeah. Yeah, if anybody needs an ad code, I've got ad codes.
Yeah, just take your keys. Take your Why?
But you just kept saying ends. I was like, that's a lot of ends. Okay. Okay. Yeah. Oh, okay. So which one do first? Start, stop, so hard dots. And then last one is N-O-G-H. Perfect. Perfect. Okay. So you have to say this one there. If you want to like type in your phone or write it down. Alright, the only reason I write it down is so I know somebody's going to hack or something, but I'll give you another. So yeah, dollar in the syllabus too, if you don't forget, but it's 100 for 4 tests, so it's 400. And then the final is 200 points. So that's 600 total, and then it's about 45-ish, 42, somewhere in there. Yeah. All right, I'm gonna take just some attendance, so people kind of come back from break, and so take another minute. So Ruth, okay,
I go by Ruthie.
Ruthie, okay. All right, and then Isabel,
Here.
Well, I've got Isabella and Isabella. So Isabella, Basal, okay. Ruthie, Isabel. Gonna learn your names. Might not be like day one, week one. Okay, Michelle, Cassidy. Michelle, Ruthie, Isabel, Michelle. Okay, and then Isabella Correa. No Isabella Correa. Okay, and then Danielle Duran. Okay, that's fine. I had a Daniel Duran at Cabrillo last semester, so I thought it was the same Daniel taking the class. Danielle. Okay, Danielle.
Where's glasses?
Daniel.
Yeah.
Probably did, yeah. He was a big guy. Big guy.
Oh.
No. A lot of Duran. Duran. Okay, Shannon Finnegan. Shannon. Okay, Grace Gamble. Grace. And then Jose Groves. Jose. Isabel, Grace, Michelle, Danielle, Shannon, Jose. Okay. Emily, Kathy.
Yeah, it's weird.
It's okay. I probably won't say it ever again. That's okay. So Emily. And then Henry Mason. Henry. And then Miguel Melgoza. Miguel. Okay. And then Jessica Nelson. Okay. And then Kaya. No. Okay. And then Betsy. Betsy. And then Yari. Am I saying it right?
Yeah.
Okay. Yari. Okay. And then Freddie or Freddy's? Freddie. Okay. Freddie. Yari. Freddie. Yari. Betsy. Freddie. Yari. Betsy. Emma. Jose. Michelle. Shannon. Isabel. And okay. Marissa. Which one? Marissa. Okay. Marissa. Joe Sanchez. Joe. Nice to Joe. Okay. And Alana. Is it Alana or Elena?
Alana.
Okay. And then Karina. Okay, Karina. Okay. And Sarah. Okay. And Nicole Williams. Nicole. Okay, and then going back through the other names, Isabella Correa.
I go by Bella.
Bella. Okay, Bella. Okay, and then Miguel. Jessica Nelson, and Kaya. Okay. See how many I can get. Okay, shoot. So Isabel, Grace, Sarah, Betsy, Freddie, Yari. Ooh, well, that's hard. I'll go back. Ooh, Joe, Henry, Alana. Whoa, all the way at the beginning. That was a long time ago. Spell your name different, say your name different. Ruthie. Michelle, Shannon, Bella. Ooh, let's go over here. Jose, Arta, Miguel. And we got, there's a story, Danielle. And it just came in. And then we got Emily. And we got, 3 people left. It was, you said it, Marissa, not Marisa. Ooh, it's so hard. I have to look. What was it? What's your name? Karina? No. Karina. Or was there? Nicole. Karina. Nicole. Okay. All right. Okay. We're getting there. Lots of names, one day. Okay. All right, so one last thing. I'm just going to tell you about order operations. You don't need to write it down because I'll mention it later when we really start doing order operations. I can kind of tell a lot about people's math understanding by the way they write, just how close together certain things are and how spaced certain things are. I'm like, do you really see kind of what's going on? And something that, you know, has always kind of helped me visualize, you know, some of my goings on in my brain is probably weird to others, but it works. Okay, so like if I see 2 times 5 minus 3 divided by 3 minus 1 times 6, okay, when I see that, what goes on in my eccentric little brain is I see these islands, okay? I see these islands, which are called terms. And we'll come back to this, we'll define terms, we'll talk about it. And here's this island, and here's this island, and they're separated by these vast oceans of plus or minus signs. So to me, when I see this, I see 2 times 5 as a little island, and then there's this huge separation of this minus sign. And then there's a 3 divided by 3, that's this other block. And then there's this minus, and then there's 1 times 6. And so mentally, I see such a gap between these things. They don't affect each other at all until after that multiplication and division is settled. And that to me really helps with that, oh, okay, obviously first I get 10, then minus 1, then minus 6. And to me, I would never, and I mean, it's a common mistake when you're first starting to have something like 5 minus 2 times 3, to just say, 5 minus 2 from left to right. You know, as I'm reading it, I read this first, so this is 3 times 3 is 9. But that'd be totally wrong, right? When you first look at that, to see this division sign is so much closer and more tightly knit, such a deeper bond and inseparable, that I have to do that first. And so this has to, only one way to interpret this, be 5 minus 6 equals negative 1, right? And that's hard for the poets and the English majors out there. Only one way to interpret it. So rigid. If I don't do it your way, I'm wrong. And that's not the way to think about it. The beauty of math is you can always ask why, and there's always a reason. It's never arbitrary, right? And I mean, I could spend an hour talking about how all this is, all these represent is 1 plus 1. It's like, okay, we got tired of writing 1 plus 1 plus 1 plus 1, so we said, let's call that 5. And then we got tired of writing 5 plus 5 plus 5 plus 5 plus 5, so let's say there are 6 5s. So that's 6 times 5. But really, 6 times 5 is just 5 plus 5 plus 5 plus 5. It's just a shortcut for writing 5 plus 5. And 5 is just a shortcut for writing 1 plus 1 plus 1 plus 1 plus 1, 5 times. So really it's 1 plus 1 plus 1 plus 1, plus 1 plus 1 plus 1 plus 1, plus 1 plus 1. So really all math is just 1 plus 1. And then we built this pyramid of shortcuts. And so the order of operations is just which shortcut do we have to expand first before we expand the other, to keep all the numbers the way they should be. And I could spend so long talking about that. I love math, right? I mean, I've been doing it since I was a kid. I've never left school. I went to, one school and then another school and then another school, and I turned around and started teaching people, and I went from one school to another school. I continued, right? I just literally finished my last day up at my private school on Friday, and then I'm here on Monday, right, at a totally new school. Yeah.
Do you think if you weren't teaching math so long, you'd still like it?
Oh, yeah. But I mean, for me, it ties together with so much stuff, because like, my favorite things to read about are science and math, and I read, like the reason I love driving, I drove over here this morning, it's 45 minutes, is I read nonfiction books about science, to me it's the same thing, science and math, it's just, and I don't actually think I'd enjoy sitting in a laboratory and like droplet looking at a microscope, but I like reading about what other people do. They do the boring stuff and then simplify it and say, here's the reason. And so I mean, I love reading the nonfiction, and the reason is like you can always ask why, and I hated English class and history class where they'd say, memorize what year this war was in. I mean, I don't care, no, not useful to me at all, right? But And the whole idea of like, what does this picture mean? And I'm like, well, I think it means this. You're wrong. Don't you get it? You know, it means this. And you're like, I don't care. Like, this doesn't affect me, right? And I could go to the next English teacher. They tell me it means something different, right? So I love math. I love science because you can always say why. You can walk outside and say, why is that tree green? I can look it up and know, right? Why is that tree 6 feet tall? Why is it there? Why anything, right? How does it work? And you can always ask why. And that's what I love about math. I love about science. There's no stopping, right? My 2-year-old never stops asking why, ever. I mean, you could get to such a point and it's like, well, why? And you're like, okay, well, let's go a step deeper. And then it's like, why? And it's like at a certain point, you're like, I don't know how to go any further with this, but I'll try, you know, because I don't want to shut you down and keep the curiosity. Okay, anyways, on a tangent. But good question, yes. No, even when I'm not teaching, which is not that often, I'm reading about math, I'm reading about science, because I just love it. Okay. And I'll often come in and be like, you know what I just read about in the news yesterday? It's crazy. What I love is when people, like my friends, will read like a science or a math article and then ask me about it. Be like, wait, could you explain this to me? I'm like, yeah, I can. Let's talk about current event math. That's cool. I had one of my friends who was a history teacher read an article about infinity. And you guys probably don't know this, but there's different amounts of infinity. And he asked me, he's like, could you explain how there's different amounts of infinity? Like there's infinities that are infinitely larger than other infinities. And I was like, yeah. I wrote him this huge email, and then we ended up talking at breakfast about it. And I was like, isn't that crazy cool? You know, for somebody to be like excited about different cardinalities of infinity. I was like, yeah, this is, that's rare, but exciting and fun. Good breakfast conversation. Okay. Let's see. So this is the last piece of section 1.1. And what that is how to check if something's a solution to an equation. And this is another important one because it comes out over and over and over and over. And just big spoiler alert, this is going to be a question on a test with words where I will ask you, what is the solution? And it might not be to an equation, it might be to a system of equations, it might be to a line, a linear equation, a parabola, whatever it is. But at some point I'm probably going to ask you, what does a solution mean? What does a solution look like? Right? And the big idea is, when you plug a solution into an equation, you get a true statement. Okay, for example, you might get something that looks like 4 equals 4. If I plug something into an equation, and I get 4 equals 4, that is a solution. Regardless of what it looks like, it can be x cubed to the 7 minus, you have no idea what it looks like, it's a graph in 3 dimensions, doesn't matter. If you plug in the numbers, and you get something true, it's a solution. That's the most important thing, and that will come up over and over again when we're dealing with one equation. When we're dealing with one equation that has 2 variables, which is a graph, it's a line. When we're dealing with 2 equations, this will happen, it's a system of equations. When we plug something in, and everything is true, it's a solution, okay? And just to be even more clear, when you plug in any non-solution into an equation, it's false. Right? So an example of that might be 3 equals 6, right? Obviously not true. So that's a really quick way to check things. Like, for example, I've taken a lot of standardized tests in my life, and I still tutor kids when they're taking, SAT, ACT, and very often they'll say something like, solve this equation, big ugly equation, and they say A, it's 0, B, it's 1, C, it's 2, D, it's 3. It's like, okay, I'll give you a hint. Instead of solving the equation at all, why don't you just plug in 0? If it works, that's the solution. Plug in 1. It's an easy number to plug in. If it works, that's the solution, right? And that's a really easy way to get the answer without doing any of the work for solving. Okay, so that's what a solution does. And that's where this section wraps up. So now we're just going to do some examples from section 1.1. And the way this book works is every time I do an example from an even problem, like say 32, that problem is going to be the exact same with a different number. I mean the exact same everything, same type of solution, same steps involved as the odd number right before it. So when we do problem 2, it's the same as problem 1. When we do 32, same as 31. When we do 74, it's the same as 73. So you can look back at problem 74 to see how to do 73. Okay, and again, I would just leave this class, get some food and some fresh air, and go sit in MLC, do some homework, ask for help immediately after class. That's my personal advice. Okay, so let's do some quick examples.
Mr. Bragg,
Yeah.
for when it's not equal, do you want us to cross out the equal sign?
Yeah. The only reason I wrote that is because if I wrote this, that would now be true, right? Because 3 is not equal to 6. So that's why I wrote it as equals, so that it's false. But yeah, that's a good question. Yeah, if you wrote this, you would say 3 is not equal to 6, and then you would say, so it's not a solution. But I just didn't want to be, that's like a double negative. It's false, and then by putting the not, it becomes true. So, hi, welcome, come on. Yeah, more the merrier. Okay. All right, so let's do a couple examples. Right, so an example from the very beginning is something like evaluate each expression for x equals 4, and problem 2 is x plus 10. Okay? So at first, this gets really easy. At first, it's obviously, okay, we got 4 plus 10, it's 14. I will say, to avoid negative mistakes, to avoid multiplication mistakes, it is often easy to just rewrite the entire expression, but with an empty parentheses, where the x used to be. And the reason I do that is that saves you from so many, especially negative mistakes, but also some distribution mistakes. Okay? And then I go, okay, what am I plugging in? I'm plugging in 4. And then there's nothing around the parentheses, no negative signs, so we're not worried. So 4 plus 10, 14. Got it. Okay? Gets a little harder when we get to something like, 12. Okay, so 12 is 5 x plus 3. Yeah. All right, so again, you would rewrite this whole thing, 5 blank plus 3. And what I would do is I would just put some parentheses there and say, okay, this is a 4. And again, there's nothing next to it, there's no multiplication or anything. So it's just 4 plus 3, nice, just to be safe. Okay, so 5 times 7, because we do our parentheses first. 5 times 7, 35. If that addition or that multiplication becomes hard from you, I know there's actually diagnosed learning disabilities, dyscalculia, or something similar to that, where just adding and subtracting or multiplying simple numbers is difficult. You're allowed a scientific calculator always in this class. During tests, during quizzes, I don't even know if I'll give any quizzes, on homework, always. You can always have a scientific calculator. Not a graphing calculator and not a cell phone. So just saying, if the multiplication, if it's 12 times 16, just turn to your calculator, use it. Okay, always. I'm never gonna hold that against you. Okay. All right, and then one more. Gets a little bit harder. Let's see, now it says, same thing, but for the next problems, it's evaluate the expression for, and it gives you 2 values, for x equals 7 and y equals 5. Okay? So an example is, as hard as it gets, number 24. Okay, this would be something like 2y minus x plus 24 all over 2x minus y. So you see now already things are picking up speed. Okay? So what I do, I'm going to erase these first examples so we have a lot more room. Okay, what I do is I rewrite it with empty parentheses. Okay? So I go, okay, I've got 2 blank minus blank plus 24 all over, and then I've got 2 blank minus blank. Okay, so I go, okay. So this first one and the second one on the bottom are both y. So that's a 5 and 5. Okay? And this lets me do it calmly and not in the moment, like this is a 5, this is a 2, this is a 7. Okay? And then the other two, these two are x's, so they're both 7. 7 and 7. Right? Now, absolutely, because this horizontal line means there's parentheses on top, there's parentheses on bottom, you could never, ever, 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 okay, cancel any one of these with any one on top. Yes, there's a 5 here and a 5 here. Yes, there's a 7 here and a 7 here. Yes, there's an x and an x, a y and a y, a 2 and a 2, a 2 and a 24. Absolutely never this entire semester in your math career could you cancel one piece of this group with one piece of this group. If there is ever an addition or subtraction sign, life is more difficult. Now you might think, no, in like first grade we were doing addition and subtraction, it's easy. Addition and subtraction make polynomials, means poly means many, nomials means terms. So as soon as you make more than one term, life gets so much harder. And that's, we're going to study polynomials for the whole rest of this class after chapter 2. Or maybe after chapter 3, after chapter 3. But that's way harder, way harder. So addition and subtraction signs make life so much harder. We hate them. We like monomials. We like when it's just multiplication, division. It's just one big Play-Doh chunk. And you're like, times, divide, just mush it around, and there's one number. That's easy. Okay, as soon as there's that addition and subtraction, you can absolutely not cancel one piece with one piece. You have to simplify the whole thing. So order of operation says multiplication first. So this becomes 10 minus 7 plus 24 all over 14 minus 5. And so we're seeing that order of operations immediately. Can't cancel one thing from the bottom, one thing from the top, and we have to do the multiplication division step first. Okay? And now, I'm going to Smoto. I find it easier, so I'm going to say this is plus a negative 7. So I'm going to say, okay, on top, 10 plus 24, that gives me 34 plus a negative 7. On bottom, 14 minus 5 is 9. And then 34 plus negative 7, 34 minus 7 is 27 over 9, which becomes 3. Right? That's as hard as those problems get, so don't think that's like a middle stab and it gets even crazy. That's the hardest one. I purposely want to show it to you so there's no like, oh my god, this is way harder than we did in class. Okay. Then the next problems ask you to check if a number is a solution of the equation. And that's why we talked about how do you check that? Okay, so some other examples from the homework would be determine whether the number given is a solution. Now you don't that often see the way they wrote this. It's a kind of confusing way to write it. So this problem, which is 44, is written as x plus 17 equals 22, semicolon, which you do not see that much. It's maybe the only time you see it, all class, 5. So it's just giving you two pieces of information, and the semicolon is saying these are totally separate. Okay, so really it's saying, here's the equation, and here's the number to check. Is this a solution? So what do we do? Plug it in. Yeah, just plug it in. So 5 plus 17 equals 22. Simplifying both sides, that's already as simplified as we can get. 5 plus 17 is 22 equals 22, check. So, not done, that is not the answer. What would be the answer to the problem?
That 5 is the solution.
Yeah, 5 is the solution. So you would say yes, it is a solution. Or you could just use the word solution, but being as clear as possible. As too often on tests, people just do this. And I'm like, well, you showed the word, but the question was, is it a solution? So yeah, you have to actually say yes, it is a solution, or no, it is not a solution. And then finally, one other one. They're all like that. There's not really any tricks. So maybe 48 is 5z equals 8, semicolon, 5z equals 30, semicolon 8. So this is that spot where using parentheses helps. Putting in an 8, you guys might all laugh, like I wouldn't make that mistake. But you would not plug in 8 like this and say 58, right? Whenever there isn't a sign between the number and the variable. That's why I put parentheses. Now it's obvious, oh, it's 5 times 8. So that's where those parentheses save you from a distribution thing. It'll more often save you from making a mistake. Okay? So 5 times 8 is 40. 40 is equal to 30. No. So you would just say not a solution. All right. Perfect. All right. Time for 1.2, which is everybody's favorite, fractions. Okay, fractions are actually super important. The reason I say that is not just in terms of like getting an answer that you're gonna say the answer is 2/3 plus 1/3. More so, because all fractions are division. I actually love fractions. I hate decimals, but I love fractions. To me, decimals are so ugly and clunky and but fractions are beautiful. It's a whole nice pretty integer over a whole nice pretty integer. It's like 3/6, and when you cancel, it's like, oh, there's a whole 3 here, and a 3 here, let's just simplify. There's never an ugly, like, 3.725 kind of ... goes on forever, and, to me, I love the fractions, So, we're gonna talk about the basic rules of fractions. Okay, and then we're gonna do some practice problems about fractions. There'll be no surprises. Okay, I don't have any magic words of wisdom. These are just the basic rules of fractions. Alright. So, first things first is how to turn a mixed number into an improper fraction. Because that's the first problems on your homework. And the first step whenever you're doing any fraction problem is you need to be able to turn 1.2 fractions. Is you need to be able to turn a mixed number into an improper fraction. And similarly, you need to be able to turn it back into a mixed number, which will happen way less often. Some math teachers would say at the end of a problem, even books sometimes, would say you have to answer your question as a mixed number. I am not that way. I think that's an arbitrary last step. You are 100% welcome and absolutely encouraged, if you get an answer like this, to just stop there. You're done. Okay? That's fine. Just as, I like if people ask why, somebody might ask, well, what's a proper fraction? So a proper fraction is any time when the top number is smaller than the bottom number, so something like 3/5 would be a proper fraction. Okay? So people might ask, why do we even use these? Why is one more useful than the other? So this one is useful for real world understanding.
numerical value, right? So this is what we use in everyday life, right? Quick example is, I ate 3 1/4 pizzas. That would be a lot of pizzas, but whatever. It's my example. The pizza lover, right? Versus, no one would say, I ate 13 1/4 pizzas. Right? No one would say that. You would say, I ate 3 pizzas and 1/4. Right? Or if you said, how much money do I have in the bank? You know, it wouldn't be very helpful if the bank said, you have 177 thirds. Okay, well, I have no idea what that means. Okay, so it'd be much more helpful if they said you have $62.33. Yeah, that was close. I don't think that was actually right. Okay, but so in the real world, it's much more important to know the whole number. And then the fraction, it's like, yeah, whatever. The decimals, I don't really care about as much. I want to know the whole number. Okay, so that's why at the end of problems, some teachers and some books say, turn it into this, because you want to know, okay, that big fraction clunky thing, is that near 17 or is that near 1,000? Right? So that's why you do that at the end of a problem, is so you know it's about 3 with some leftover. Okay? Whereas this is useful for any and all math. I'll make that really general statement. So before you do anything having to do with math, add, subtract, multiply, divide, plug it in, solve an equation, graph it, any single thing you want to do, you're going to turn everything into an improper fraction. You never, ever, ever want to deal with these. The reason is, let's say we had 3 1/2 times 4 1/5. Okay? If we turn it into improper fractions, that's a super easy problem. However, if we leave it like that, this is really saying 3 1/2 times 4 1/5, and there's that stupid plus sign. And all of a sudden this is a binomial times a binomial, and you gotta FOIL this. You gotta say 3 times 4 plus 3 times 1/5 plus 1/2 times 4 plus 1/2 times 1/5. And that's terrible. No one would ever solve that problem that way, right? Much easier is turn it into one cohesive improper fraction and then multiply it. So this is gonna be the first step every time. So I'll tell you the general steps for solving fractions. And very often, as we're doing notes, I'll give you the general steps, which will be like 3 steps or 4 steps. It's kind of the big picture, because to me, I'm totally a big picture guy. The details never interest me as much, and that's why I don't work in a laboratory doing science, and instead I just talk about big picture science and the birth of the universe and stuff, because that's way more interesting. Okay, so your overall strategy might be a better way to write it. Okay, is step 1. You always turn all mixed numbers, into improper fractions. Okay, step 2. Do the arithmetic, which is what we're going to worry about. So the arithmetic means add, subtract, multiply, divide, in order. And then step 3 is reduce, or call that simplify, whatever you want to call it. Okay, so every fraction problem starts by turning every mixed number into an improper fraction. Every single one, the entire problem. Then you do whatever it says, multiply, divide, add, subtract, and always, your last step is to simplify. Okay? And you can ask why. You can always ask why. The reason is there's an infinite number of ways to write any fraction. So let's say we have 1/2. We can write that in an infinite number of different ways. We can write that as 2 fourths, 100, 2 hundredths. We could write it as pi over 2 pi. We could write it as -6 over -12, right? So there's an infinite number of ways to write 1/2. I don't want to read an infinite number of answers. I want every single person to simplify every fraction, so that way I know every single person should write exactly 1/2. And if you wrote any of the other answers, I'd give you like 4 out of 5 points, 9 out of 10 points, 72 out of 73 points, right? But you can't get full credit unless you simplify. So that's the last step always, anytime you see a fraction. And that's the beauty of a fraction. Whether it's a fractional exponent, whether it's a fraction as, you know, your solution, whether it's a fraction of anything, a ratio, a slope, it can be anything, you can always simplify it. It's always exactly equivalent. It's the beauty of fractions. Okay? So let's talk about how to do the arithmetic. That big second step, which just says order of operations and lots of rules of how to multiply, add, subtract, divide. Okay. Let's take a quick pause before we do that. One thing I want to mention that I didn't mention, it's because I was trying to get the computer working and I couldn't show it to you, is Khan Academy. Okay, and I'm not like a salesperson for Khan Academy saying spending money, it's free. Okay? But I really believe in Khan Academy strongly. And what Khan Academy is a website where it's a cool story. It's this guy, Saul, and he tutored his, some relative in calculus by making videos and putting them on YouTube. And then just random people start watching the videos and then saying hey, could you make one about this or about this? And then he started making more and more. And then eventually got to the point where he was making little income from that, so he could quit his job. He started making more videos, and all of a sudden people like Bill Gates and famous rich people were here's lots of money, hire people and make lots of videos and a huge website. And so what he has now are video lessons for everything you can imagine. And personally, I think his video lessons are extremely boring, and I've never watched one all the way through. But that's not the reason I love the website. The reason I love the website is it has free practice problems that immediately make fun sounds like, "Ka-ching, you got 1,000 points, you got it right, you got a dragon gold star." Or, if you get it wrong, it has hints, it has guides, it has calculators that you can click on. But the nice thing is, I don't know how to do this problem. So you go over to the hint, and by showing hints, it'll show you one step. You go, oh, right, and then you solve the rest of the problem. Or you go, still don't know what to do. You hit hint again, next step, next step, next step. And by the last time you hit hint, it gives you the final answer. So there's no point at which it stops and says you can do the rest. It'll literally show you every step. And you can keep practicing problem after problem, and it generates new problems, and it's get 5 in a row to move on. But you're free to do whatever the heck you want. You can do it on your phone, you can do it on, a laptop, you can do it here in the MLC. So I put on the class website links to practice all these things. So for example, as we're going into fractions, if you, finish the homework in the book, or you just say, I hate homework, I'm not going to do it, you could go online. I have links where you can click on Go to Khan Academy, and there are these engaging little problems that are addictive. Like, for example, I was doing some interviews last semester, and one of the interviews had a big math test. And all it said was college math. I don't know if you know about college math, but it's a pretty big topic, right? It starts with basic algebra and goes in 10 different directions, like calculus and differential equations and linear algebra and statistics, and there's so many fields. And I hadn't taken college math in 10 years. I've been teaching middle school and high school. There's not a lot of advanced math in middle school and high school, so I was like, oh, I should review. So what I did is I went on Khan Academy and just did practice problems for calculus and for statistics and for differential equations. And they just keep popping up and they're addictive. You're like, mastery challenge. And it's you mastered 3 new skills. And then it gives you a new problem. So you're like, oh man, how do I do that one? And it's just fun and engaging, and they're quick and they're simple. But that's a place you can go to immediately practice skills. Okay? And I wish I could figure out how this works. I'll try and get it working by tomorrow or the next day. And I'll click on it for you. I'll break the ice for you. It's really easy to click on, absolutely free. For me, I clicked sign in with Google with my Gmail, and so then it keeps track of everything for me, and I can always redo it. I didn't have to make a new account. I don't think I've ever gotten an email from them.
spam or anything. I didn't sign up for an account, I didn't pay any money, but it keeps track of everything for you, and it allows you to progress through whatever you want at any speed. And again, I mean, the modern world, man, you can learn everything you need for this class without ever showing up to class. I mean, it's all out there, you know? I mean, I'm a human being that you can ask questions and be in close proximity to, and we can have this emotional bond, and I can help you through it. But really, it comes down to you going home, putting in the effort, and really spending time in what otherwise would be summer, and everybody sure has jobs. I don't know, maybe some of you are rich, and just, you know, you go to the beach all the time, you don't have to worry about money. That would be awesome. But I mean, it's gonna be hard during summer to put in those hours, but it's really important. Khan Academy is a place where you can get some practice, okay? All right, so hopefully I've impressed upon you the importance of hard work. Okay, so fractions. First, okay, so multiplication is the easiest. So we start there. Multiplication is always the easiest. People always think it's addition. Addition's terrible. Subtraction too. Okay? So a quick example. Okay? 3/2 times 5/7. I specifically chose proper fractions, prime numbers, nothing cancels, nothing reduces. Okay, so how do you multiply?
Just go straight across.
Straight across, that's it. So multiplication of one fraction times another is the same thing as 3 times 5 over 2 times 7. And I will totally make mistakes. If I make a mistake on a problem, just call me on it. Right? I do so many problems and I'm focused on you guys and what I'm saying with my mouth and what I'm writing. I sometimes make mistakes. So 3 times 5 is 15 over 2 times 7 is 14. It's as easy as that. Okay? And my explanations will try and be in as common a language as I can, as simple as I can make it. So multiply the tops. And multiply the bottoms. Right? If you want the vocabulary, top is the numerator and the bottom is the denominator. I won't be big on vocabulary, but every now and then I'll say this is a very important vocabulary word you need to know. But overall, oh well. Okay, and then reduce if you can. Okay, it's always the last step. Okay. And we'll do a lot of practice problems together. But first, I want to show you how to do these. Okay, next is division, because it's almost as easy as multiplication. Right? How do we do division? So, for example, again, I'll do all prime numbers, so nothing cancels at all. So 2, let's say 11ths divided by, let's go 5 13ths. Okay. Alright, so there's one big step. What's that one big step?
Flip it.
Flip what?
The reciprocal.
Yeah, the reciprocal of the, which one?
Second one.
Second one. So always, just like when you have 5 minus 3, this negative sign only affects the thing after it. And that's why when I have something like 5 minus 2 plus 7 minus 6, and I'm adding and subtracting them together, when I circle a number, I circle the sign with it. Okay? Those signs only affect the thing after it. So this division sign only affects the thing after. That 2 11ths doesn't care that there's a division sign after it, or a subtraction, or a multiplication. It doesn't care. That's the rub. Okay, so yeah, first things first. Flip the second fraction. That's called the reciprocal. And change the sign to multiplication. Okay, and then I'm going to give you one hint with this to save you from a common mistake. So this becomes 2 11ths times 13/5, right? And then it's just multiplication, right? We already did multiplication. And just, you know, as we go forward in math, it'll always be this one new little baby step, and then it's that same old thing,
right? So now we've already learned multiplication, so we'll say one new step, and that's multiplication. Okay? So this would be 2 times 13 over 11 times 5, or 26 over 55, which you could check, could you reduce? I know it's made of prime numbers. So I know nothing cancels, I'm 100% sure. All right, so that one hint is, over here, and I'm gonna specifically say with multiplication only, okay? Absolutely not with division, not with addition, not with subtraction, only with multiplication. You can cancel any number on top with any number on bottom. And just to even be more clear, addition and subtraction ruin this. Right, this is only when there's not addition or subtraction. So for example, okay, if this, man, if that was a 6, you could cancel this 2 and this 6 and say 1 and 3. Or, if that was a 4, you could cancel this 2 and this 4 and reduce it. Okay, any number on top with any number on bottom. Alright, whereas over here, you cannot cross cancel with division. Okay, you absolutely cannot cancel this number with this number, or this number with this number. That's a really common problem. Okay, I'll give you a quick example. Okay, so let's say 1/2 divided by 4/3. Okay, what should that be? How should that turn out? What should we do?
1/2 times 3 over 4.
Yeah, it should be 1/2 times 3 over 4. Then you would see, can I cancel? No. 1 and 3 don't have anything in common with any of the numbers on bottom, so this is just 3 over 2 times 4 is 8. Okay, that's what it should be. However, at the beginning, I'll write not. So a common mistake is divided by 4/3, canceling this and this to be 1 and 2, and saying this is equal to 1 over 1 divided by 2/3, which is 1 over 1 times 3/2, or 3/2. What you actually did there was canceled something on the bottom with something on the bottom, and so this top stayed the same, but you changed an 8 into a 2, totally changing the value of the problem. So never with division could you cancel or reduce or simplify. All right. Now addition and subtraction are the same thing, so I'm going to do them together. Okay? And this is it. This is the last how to deal with a fraction. And then we'll just do some practice problems. So first, find the common denominator. And people could ask, why? Why do you have to do that? Great question, class. Right? The reason is, what if I were to say, what if I were to say, I have 3 bananas and 5 apples? How many do I have?
8.
8 what?
8 fruits.
Why fruits?
Is there any sort of variable?
Ah, because that's what they have
No.
in common, right? You wouldn't say I have 3 bananas and 5 apples, and I've got 8 apples, or 8 bananas, or 8 banapples, or you wouldn't just somehow smash them together. You would have to find something to have in common. You would say, okay, I have 3 bananas and 5 apples, so that's 3 fruit and 5 fruits, I have 8 fruit together, because that's what they have in common. Same thing with fractions, right? Thirds and fifths are totally different things. So you have to somehow see, okay, well, if I'm going to add these together, I have to say I've got how many 15ths and how many 15ths. Oh, so total I've got that many 15ths, right? So you have to figure out what they have in common, okay? Then add the tops, and don't add the denominators together. Tops only. Okay, and then simplify, or then reduce. Okay, so let's do an example or two of this, because these are the harder ones. Okay, so here's an example. Okay, this is number 70 from nearby. So 5/16 plus 1/16. Always in this class, in math, we start out with baby steps. So we don't need to do the first step in this one, right? It's already got a common denominator. So what's 5/16 plus 1/16?
6/16.
Yeah, it's like 5 cars plus 1 car, so you've got 6/16. That bottom is just talking about the size of the slice. So yeah, I've got 5 of them plus 1 of them, so it's equal to 6 of them. And then the last step is reduce by 2. Yeah, they both got a 2, so I'm going to divide by 2, divide by 2. So this is the same thing as 3/8. Wow, it's the same as that other problem. Alright, so let's do another example, this one where we have to find a common denominator just so we can see how we do it. Okay, and then we'll just throw up a couple problems from all different types. Okay, so, wow, 3rd or 5th, that was the very problem I said just a minute ago. It's like the book is reading my mind. Or it's like I've looked at the book. Either way. Okay, so 1/3 plus 1/5. Right, so first, common denominator. I find a common denominator. What's the common denominator?
15.
Yeah, so sometimes you can find a smaller, simpler one, but rule of thumb is you can always just multiply this number times this number, and that will give you a common denominator. Sometimes there is a lower or least common denominator that is different, a smaller, shorter, right? For example, if I had 1/2 plus 1/4, multiplying these, you could say 8 is a common denominator, but a simpler common denominator before. Okay, so anyways, yeah, so common denominator is 15. How would I turn both into 15s?
1/3 by 5 and 1/3 by 3.
So
Top and bottom.
yeah, exactly. So not multiply by 3 or multiply by 5, but multiply by 5 on top and on bottom. So that way you didn't change the fraction at all. Because multiplying by 5/5 is the same thing as multiplying by 1. Right? So that's why, yeah, we multiply it by 5 on top and bottom. Multiply this one by 3 on top and bottom. We're going to do this a lot in this class. We're going to be dealing with equations that have fractions. We're going to be dealing with slopes that are fractions. Very often we will be adjusting them. We even deal with polynomials as fractions, where you're factoring the polynomial on top, factoring the polynomial on bottom, figuring out common denominators of polynomials, and saying this one has an x plus 2, and this one has an x plus 3. So I need to multiply the top and bottom of this one by x plus 3, top and bottom of this one by x plus 2. So this happens, this idea comes up a lot. So now we have 5/15 plus 3/15. Adding together, what do I get? 8/15. Okay. We don't change that bottom number because it tells us what we're talking about. It's like fruit. 3 fruit plus 5 fruit is 8 fruit. Wow, that was the exact numbers before. Okay. So, nothing in common with this, right? This is just made of 3 times 5, and this is just made of 2 times 2 times 2. Right? So you can always break a number down to its primes to be 100% sure this is exactly what it's composed of. So we know it doesn't reduce, so we're done. Okay? So what I'm gonna do right now is I'm gonna write some problems up on the board. We'll do odds, so they're from your homework, so we'll get your homework started. I'll write some odds up on the board. You guys can work on them. If you have a book, great. If you don't, somebody can use mine. You can scooch together and make a friend. Also, the Math Learning Center has these books. So if you don't want to buy the book and you can just commit to every day after class, I'm gonna leave class and go to the NLC and do the homework, that's awesome. That would be a little hard, because then if you wanna study for the test, and you're like, well, now I don't have problems, but that's what Khan Academy's for, that's what your past homework's for, that's what, the practice tests I give you will give you everything you need to practice. So, if you want to commit to that, that's great. But we will do homework problems in class. How many people have a book here? Just curiosity. Yeah, so almost every other, almost. Okay, so I will, these first couple days, I'll write the whole problems up on the board, so you don't need a book. But in general, very often in this class, I'll say, okay, now we're gonna spend 15 minutes doing problems. Because you can't just store 3 hours of information, go home and be like, yeah, I remember. It's like watching Tony Hawk skateboard. It's like, yeah, I saw him, it looks easy, I could do that. And you actually go to the skate park and you come home with like a broken arm and scrapes and bruises, right? So watching me do it seems simple, but until you actually get your hands on a pen or pencil and write, I would recommend a pencil because mistakes are welcome and encouraged, just learn from that. But until you actually do that, it's hard to learn. So very often I'll say, do it, and then we'll come together and ask questions. I'll walk around the class and help you. And that's not like free time, like man, I don't have anything else to teach you, just leave. It really, really is an important time for you to get some work done. All right, it's all right, listen. All right. So, this is let's go with number 5. Ooh, that's a little bit. Let's go with number 3. Okay, so 7 3/5. Turn it into an improper fraction. Okay, number 10. Turn an improper fraction. Into a mixed number. Oh, we didn't go over how to do that. It was in my notes and I skipped it. We'll go over that in a second. Okay. So 59/9. Okay. Section 1.1 page, or section 1.2 page 29. Alright, so I'm gonna let you guys do 3 and 10 even though we didn't talk about it. And then we'll talk about how to do it after. That'll get better. Yeah, if you got questions, raise your hand. Stop by. And you can just write homework number 1, section 1.2, and start doing problems.
thought it was like, yeah. And I didn't know it was like, it's all from our own, like, it's there. And I was just like, oh, that's that. Information of like capacity, is that right?
Alright, so could I have volunteers come up and write the problems on the board really quick? There's black markers, there's colored markers, there's red and purple and green, and there's no blue, sadly. You don't need to raise your hand, you don't need to say your name, you don't need to say words, you can just stand up, walk to the board. Thank you, I see people moving. No, there's lots of problems. Stand up and walk the board for any problem. Even if you get up there and somebody did the problem you wanted, you can just walk back and sit down, that's okay. Right, stand up. There's 6 problems and only 3 people so far. 4 more, 2 more. It's okay, no one's gonna judge you, it's a safe place. And if people do judge you, they suck. Right, so you stand up. Right, come on, 2 more people. It's okay. One more person. Be brave, embrace life, carpe diem. All right, I'll do the last problem. But it's good, we'll slowly work up those nerves. So yeah, first one, the way you do this is perfect. Just set it up, show the work, that's great. So this is how many holes you have. So if we want to figure out how many fifths that is, how many fifths are in 7 holes? Well, each one has 5, so 7 times 5, that's 35 fifths. Make up those 7 holes, plus the 3 left over. I have students in the past who used to write it like this. They go times plus as a little shortcut, and that's like a mental trick on how to remember it. But yeah, so 7 times 5, 35, plus 3, 38 fifths. Perfect. Okay, this one, if you were going to show the work, you would say, okay, so 59 divided by 9, you would do long division. Okay, and what you get is, you get 6 with a remainder, which we haven't done remainders since like 3rd grade, but remainder of 5. Right? Because you go, okay, so 6 times 9 is equal to 54 of the 59. But then there's those leftover 5. So that's why you just divide this by this. The division sign is the fraction bar. It literally means division. Something we're going to do as we move forward in other sections is it's going to say turn this into a decimal. I think we do this in 1.3. It says turn this into a decimal. You literally take your calculator and it says 59 divided by 9, so you go 59 divided by 9. And it says 6.5555555, right? It's that easy. Okay, so it's a division bar. So you just divide, and this time we're looking for a remainder. Right, so this one perfect. Divide the top by 5 and the bottom by 5, 7/10. 7's the prime number. So you can't go any further. You're done. Okay, this one. The trick being, when you have a whole number times a fraction, you put it over 1, because 9 is the same as 9 divided by 1. It's the same thing. So anytime you have a whole number and you're dealing with fractions, you put that whole number over 1. And then multiplication is just top times top, 36, bottom times bottom, 7, and you're done. I prefer people to stop here, but absolutely if you want, you could write it as 5 and 7s. I would 100% mark it correct. Perfect. Okay. The only reason I say stop here is like as a teacher, I want you to succeed so badly, right? It's my like deep-seated desire, like self-gratification as a teacher. Like when you succeed, I pat myself on the back, and I'm like, yeah, it was because of me, it helped them. Right? When you fail, I blame it on you, so it's a win-win. I say like they didn't try hard enough, like it was all them. Right? So it's great for me either way. I have a smile on my face. But, okay, it's really painful as a teacher to have them get the right answer. And then the last step, to turn it into this, which you don't have to do, and then you do it wrong. And I'm like, now I have to dock you a point, and you have the right answer. Can't we just like cover that up and pretend it never happened, right? So that's why I say don't take the extra step when you don't have to, because then that's just opening yourself up to mistakes. Same time when I say like, give 2 examples of solutions, some people write like 4, and I'm like, yeah, there's no winning, like there's no extra credit, you're just possibly failing more. So like when I say give 2 examples, only give 2, because if you give 3, you don't get extra credit, but if one of them's wrong, even though you have 2 right, still you're wrong, so I have to take off points. So right, so don't do that extra step, there's no extra credit, just stop this. Just mental strategy. Okay, so this one, since it is multiplication, you can cross cancel. So looking up here and down here, you go, oh look, I can divide both of these by 2, so this becomes a 2 and this becomes a 3. So this is the same thing, and you could reduce this at the end, multiply them, get 30 over 28. Ooh, they're both divisible by 2, and you get 15 over 14. Or we do it at the beginning, and we say this is now 5 halves times 3 sevenths, which is 15 over 14. The beauty of math is it's just you can take any road you want. Maybe your math teacher's in past, right? You have to robotically do step 1 and 2 and 3 and 4. But actually, you've got all sorts of beautiful different ways. It's just sometimes in math, one way has like briar patches and thorns and painful, bleeding, agonizing, way longer. And one way is, a short little frolic through a field of flowers, right? So sometimes through pain, we will encourage you to do it one way. But there's 2 ways, right? You could have just multiplied it, reduced after, or do it this way. I think this way will be easier because it's either multiply and make things really big, then simplify, or simplify small numbers, and then when you multiply, it's still small. Right, so that way, just strategically, keep the thing small, go small first before you multiply, rather than multiplying to make hundreds and then trying to figure out what cancels out of 225 and 256. I know they have something in common, do they? Right, so much easier to cancel small numbers first. And then last one, I specifically did this to tempt you with a 2 and an 8, but we know we switch this to multiplication and flip this over rather than canceling. So this is perfect. This divided by 2/3 becomes times 3 halves. You did not fall for the trap of canceling. And then you just multiply 3 times 7 is 21, 2 times 8, 16. This is just 3 times 7, and this is just a bunch of 2's multiplied together, so nothing cancels. So you're done. And again, I would absolutely stop here, but you could definitely go to here, and as long as you get the right answer, it's just as right, just the same amount of credit. That's perfect, okay? Just to give you 1 or 2 last, hardest problems there are. We don't even need to. We don't even need to. I think people are doing all right. The one problem, just to show you, that might come up, is you might have something like, this is the hardest problem in the section. Okay, this you might have something like 90, which is 3 2/3 minus 2 1/2, which, what's important? Anybody? What's important there? That is important, that is for sure important, that the negative only affects the second thing, yeah. But also,
We can start from 3 2/3.
yeah,
And below it, right, minus 2 and 1.
yeah, you could. I know it's hard, because again, as I said, it's a wide open field, you got multiple options. Like both of those things are important, you can do that, but I would say, from our notes, the first step, yeah.
I would change it into an improper fraction and get a common denominator.
Yeah, so first and foremost, change it into an improper fraction. The reason being is if you do it like this, like 3 minus 2 is 1, 2/3 minus 1/2, this time it would work out, okay? But sometimes it's something like this, like 3 and a 6 minus 2 and 3/6. And so you're like, okay, 3 minus 2 is 1, and 1/6 minus 3/6 is negative 2/6. Like, is that my answer? 1 and negative 2/6? So then you have to borrow from the 1, and you're like, okay, well, borrowing from the 1, now that's 0 and 6/6 minus 2/6 is 4/6, and then it's 0 and 4/6, which is 2/3, and I mean, that would technically work, but there's a lot of room for mistakes in there. So much easier than trying to maybe borrow and deal with that is, yeah, just turn them into mixed numbers right away. And again, this is the hardest fraction problem to see. So times and multiply, so we got 3 times 3 plus 2 thirds, minus, and this is 2 times 2 plus 1 halves. So we got 9 plus 2 thirds, minus 4 plus 1 halves, or 11 thirds minus 5 halves. And that's just like the problems over there. We didn't do addition, subtraction, what the heck? Times 2, times 2, times 3, times 3, right, to get that common denominator. So then we got 22/6 minus 15/6. Now that we have a common denominator, we don't subtract the denominator. 6 minus 6 will give you 0. Can't have 0 in the denominator. So 22 minus 15 would be 7/6, and we know we can't reduce that any further. So that's as hard as any problem could get in this section. So hopefully this isn't, challenging you, and if it is, work harder, right? I got my 2-year-old saying that. They say like praising your child, if you praise your children for being smart, then they'll be more scared of trying new things, and they'll have, these self-esteem issues, and they'll think they're watching me and I'm failing, I'm not good at this, I quit, I'm just not good at this. So I always tell my daughter anytime she does something, I say like, well, try harder. Like she'll try and open a bottle and she can't do it. And I'll be like, try harder, and then she'll do it. And so now she says it to me. Like she'll say like, oh, find my baby doll. And I love it, like, I can't find it. And so yeah, look harder. I'm like, all right. She always says it now, it's funny. Anytime, like my wife sent me to the store for some wine, my daughter runs up and down just like the aisles and loves wine. And I was like, gosh, I can't find mommy's wine. And she's like, look harder. I'm like, all right, I'll listen. My 2-year-old's giving good advice. Okay, so I just want to write a couple addition and subtraction problems that you can do. Again, I'll do odds, so it's, from your problems. Let's do, a good one. Let's do 65, because that's a hard one, you guys. It's almost as hard as it can get. Or maybe as hard as it can get. And then 73, 7/12 minus 5/12. So yeah, these are all homework problems from your actual homework. And then 77, 1/2 plus 1/5. And one last one, 85. So all 4 of those are homework problems. Somebody asked me a good question, and they said, what is our homework? That's a great question. I did not print out homework sheets, because that would have just been a waste of paper. But on the class website, you go to the class website, which has everything, it's the place to go. It has a homework printout that you can print if you want, or you can just keep it digitally. And it has section 1.2, I'll show you exactly what it looks like. I have an old version of it. This is what it looks like. But yeah, it just says section 1.1, and there's a list of problems, 1.2, list of problems, 1.3, list of problems. And I actually need to update it, because we don't do a couple sections from chapter 3 or 4, I could just like cross those out or delete them. But anyways, this has all of the homework problems you do. Basically, either every odd from every section, or half of the odds. You never do even problems. But it'll basically say odd, or EOO, and EOO means every other odd. So like 1, skip 3, do 5, skip 7, do 9, skip 11, do 13.
Alright, let's do those 4 problems.
Jessica shown up yet? There's no Jessica, right? Okay, let's double check it. And who did not get a syllabus? Who wasn't here? Okay. And one more. Let's pass that down. Alright, anybody else need a syllabus? So again, the class website has all the information, calendar, notes, homework, tests, past tests, answer keys, everything. Alright, so when people are done, you can just come up and solve those problems. It's only 4. I'd love new people, but the same people can come up. Let's see. Piece of that. Come on up, you guys. Yeah, so again, I teach this exact same class from 11 to 1:50, so if any time you can't come in the morning, you can come then. I'll tell the people from the afternoon one the same thing, yeah.
Did you even turn in homework at that time?
Yeah, you can totally turn on. Just when you turn it in, like tell me, so that then it's, I'm like, wait, what the heck? No, I won't be confused. But yeah, absolutely. All right, so let's look at these problems. So first thing, when you see mixed numbers, immediately you turn them into improper fractions. 6 times 5 is 30 plus 3, so 33 fifths. Divided by 1 times 10 plus 1, so 11 tenths. We immediately flip this over and change it to multiplication, so it's the same 33 fifths times, and now we've got 10 11ths. And then you can simplify. 33 and 11 become 3 and 1. 10 and 5 become 2 and 1. So it's just 3 times 2 is 6, over 1 times 1 is 1, or 6. Great, that's easy. Right? This one already has a common denominator, so you just say I've got 7 of them minus 5 of them, so I've got 2 of them, but that wouldn't get full credit because reduce it, right? So just divide it by 2. It's the right answer. Right answer. But we always reduce, so that'd be 1/6. That would be your answer. Okay? And that'll get people. It'll get people. Okay? But always check that whenever we're dealing with fractions, because you couldn't reduce 7 over 12, you couldn't reduce 5 over 12. When you combine them, sometimes you can. Okay? This one, now you need a common denominator. The easiest way to get it, 2 times 5 is 10. So multiply by 5s, multiply by 2s. 5 tenths plus 2 tenths is 7 tenths, and you can't reduce 7 tenths. Okay? Over here, common denominator, 3 times 4 is the easiest way to do it. You would never, ever, ever cancel, because it's not multiplication. So, you would say times 4 is 16 twelfths, times 3 is 9 twelfths, 16 minus 9, 7 twelfths. Perfect, okay? So that's 1.2, that's fractions. There's really no other surprises, but a huge concept in math is really this stuff we do, these steps, carry forward so much because we're gonna see fractions in like 3 or 4 different lights, like totally different scenarios. And one of the biggest skills is being able to abstractly see that, oh, doing this and dealing with what's the common denominator of this, it's the exact same thing. And as long as you're careful and you see the big picture, it's not even any harder. Okay? It just takes practice to gain comfortable. But this is a chunk, this is a chunk. So if I want to see what's the common denominator, how do they go together, you're not supposed to know this yet. But just saying, if I want to find a common denominator and add these together, I would say, oh yeah, the common denominator is this times this. So I would go times x plus 5 times x plus 5. I would go times x plus 3 times x plus 3. So I would get this common denominator, who cares what it is? This common denominator, who cares what it is? And then I'm going to add the tops, just like you did up here. 5 tenths plus 2 tenths. So I would say, okay, x plus 5 over whatever that common denominator is, who cares? Plus x plus 3 over that common denominator, who cares what it is? So when I add those together, you get x plus x is 2x, 5 plus 3 is 8 over a common denominator. So it's the same idea will come up in a little more abstract of a way. And so being able to see that analogy or that comparison is a big idea in math. Because these things we learned in chapter 1 and these things we learned in chapter 2 is basically all there is in algebra. And then all we say is, well, what if instead of the number 5, we had a y there? Okay, you do all the same steps, all the same logic, all the same solving, but just instead of a 5, there's a y, right? And you really do the same chapter 1 steps, the same chapter 2 steps, but interesting things happen. There's a graph of a line all of a sudden, and the solution is an ordered pair instead of x equals 2, right? So interesting things happen, but it's the same steps. So chapter 1, chapter 2, the most important stuff in algebra, okay? So I wanted to get farther today, but I'm going slowly. Somebody with their glasses over there. I was like, this doesn't look like mine. I wanted to get a little further. I'll start going over section 1.3, but we won't go all the way through it. Yeah, and then what we're gonna do with the last about 10 minutes of class, which is 20 minutes right now, with the last 10 minutes of class, we're gonna walk over to the MLC and say hi and have them tell us a little bit about the MLC. They said come by any time, so I hope they're free and available. The MLC's right there, has books on loan, has tutors that can help you. Use it, work hard, embrace it. Okay. All right, so let's just talk about 1.3 really quick and then we will walk over to that MLC. And if you have any questions in the 10 minutes in between class, I will totally answer them, but hopefully you don't mind that I'm being told to the audience. All right. And what you'll find is, at the beginning, I spent way too much time on things that supposedly maybe seem too simple, and I already know this. And the reason is, again, here is the most important stuff. And I'm gonna assume nobody in here knows all of it, but maybe you do. That's great. Okay, then you're ahead of the game. So 1.3 is all about real numbers. And real numbers just basically means all numbers that you know of that exist. Okay? There are numbers that are not real. They're called imaginary numbers. You've probably seen them. It's just the letter I, so like 3 plus I or negative 2I. Those are imaginary numbers. Imaginary numbers are really conceptually really interesting. All it is the square root of a negative. Basically what it does is all the real numbers exist in one dimension. So here's 0, here's 1, here's 2, here's 3, here's negative 1, negative 2, negative 3, keeps going on to infinity. Every number exists in here, like pi is somewhere around here would be pi, right? Like, negative 0.76 is somewhere around here, right? So every real number is on this one line. It's either ahead of or behind, it's either greater than or less than, or equal to, right? There's a strict relationship. Often, I find it more useful to write it like this, where here's 0, 1, 2, 3, and the reason being then it's obvious what's greater than or less than, because then it's just above is greater, lower is less than. And I'll talk more in detail about this next class, but a question like, which is greater? Negative 2 or negative 5, you'd say, that's kind of hard to think about because the 5 is bigger than the 2, but it's negative, so it's the opposite, so which one? Whereas if you think of it like this, you'd say, oh look, negative 2 is higher than negative 5. So it's okay, we're going to be kind of open until the next 10 minutes or so. But you'd say negative 2 is above negative 5, so you would say this is greater than that. And the greater than sign, I don't know if you guys have ever thought about why, but it's interesting. It's literally saying, math is logical, if anything. Here's the big side, and here's the teeny side. I mean, think about it. You basically said, we're going from this side big to this side small. How could we represent that? Let's do that sign, right? Literally like disappearing into the distance horizon, like big, small. So here's the big side saying this is bigger than that. And every real number can be compared to every other real number in either bigger than, less than, or equal to. And then there's always the combination greater than or equal to. Okay, so that's what we're going to talk about a lot. Imaginary numbers, just to kind of go off on a tangent and tell you what they are and why they're useful in advanced math, is instead of being stuck on the real number line, what we do is sometimes there's problems that are unsolvable. Like, okay, so the antiderivative of e to the x squared is an unsolvable problem in real numbers. You can't solve it, there's no trick we have. However, if we just say, what if there were more numbers that didn't exist, that don't exist? You can't use a ruler and measure an imaginary number, but what if we just made it up? And a lot of math is just making something up and then walking down that road for your entire life and studying in a book, and then either your scribblings that you spent your entire life, making, become really useful to like Google or something, people in the future are like, oh my God, this is so cool, somebody spent years doing this and it's all done for us, or it's just forgotten and your life is wasted, right? But that's a lot of what math is, and some of the math people invent, they name it after themselves, they're like, this is Clifford algebra, this is Brendan algebra, like I made this up, you know, what if we didn't have the number 1, what would happen, right? And so what if we have this imaginary number axis, and so then, just like plotting points, you can go anywhere in 2 dimensions. And so what would happen is, to get from here to here, instead of going along the real number line, you could just wander through this imaginary forest, and then get there, through a different path, and using that, we say instead of integrating from 1 to 5, we integrate on a curve. And you can describe different clever curves. What if I went in a circle? What if I did 2 circles, right? And all of a sudden you can solve unsolvable problems by walking off into the imaginary number line. And then we actually end up back in a real number. So you take an imaginary journey and then just kind of teleport to another place. Anyways, it's really cool, really cool. I don't actually like, you know, I can't do this stuff anymore. I mean, in grad school I can do it, but whatever, that was years ago. But it's just cool what people do, and like, people think of this stuff and then they use it. It's wild. All right. So, last thing we're going to talk about are a couple categories of real numbers. Okay, and here are some categories of real numbers. Okay, one is the easiest, natural numbers. Right, these are the ones kids learn. Right, we write it with an N with an extra line, so it looks like that. I have no idea why. It's probably something Greek. We did a lot of stuff starting with the Greeks. So natural numbers, it's naturally how you count. You start with 1, then you go 2, then you go 3, then you go 4, then dot, 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 the pattern continues. Right? So there's no 0, there's no negatives. Naturally, when a kid learns to count, they go, I've got 1 figure, I've got 2, I've got 3, I've got 4. So it's natural. Okay? Whole numbers, I don't think there's a sign. I don't think there's no direct symbol that I know of. Let's put a question mark there. Maybe there is. Okay? But whole numbers are what got added to that. So when math first started, I mean, one guy was like, I got a sheep. Now I've got 2 sheep. I'm rich, right? And now I've got 4 and 5, and I can count. But eventually, years, centuries later, people thought of 0. How many sheep do you have? And instead of just saying, I don't have sheep, it was, I have 0. This idea of a number that is no number, that was a big revelation in math. So that's a whole number, and that's probably the most misused term. I will even, in common English, I will say a nice whole number, and I could really mean integer, because I mean -5, +7, a nice whole number. Okay, but actually, whole number means 0, 1, 2, 3, starting at 0 and only including positive. Okay, and then integers. And this will be the most common word that you see that you will need to know. Integers, which is written for whatever reason as a Z with an extra line. Okay, you don't need to know that, but just in case it ever showed up. Okay, but integers are ... every negative and 0 and positive whole number. Okay, that's the most common one. It'll say, use an integer too, or find the integer, or simplify, and you'll see that word integer come up often in problems. All it means is not a decimal or a fraction. Okay? Right. And again, people often switch these two. They often say whole instead of integers, you know, when they should be integer. Okay? And the last two, let's save them. Rational and irrational. I'll put a little mark. This is where I left off. So, let's walk over to the MLC together. You can pack up all of your stuff, bring it with us. Please don't leave and just save yourself 10 minutes. Let's walk over there, check out the MLC, ask them how it works, and then we will come, well, not come right back, we'll say goodbye, and we'll go back to our day, okay? Cool, let me bring my keys just in case anything is locked. Shouldn't be, but you never know.
Hello.